what we are doing is opening a new window onto the universe, but a window that is radically different from any other window we've ever looked through onto the universe. The other windows are all looking with electromagnetic waves, light, radio waves, X-rays, infrared. It's all electromagnetic radiation. We see the universe very differently through, with these different kinds of electromagnetic radiation. The universe looks serene in the optical. It looks violent in radio waves and X-rays. Each of these bands teaches us something different about the universe. There is an entirely different type of radiation, gravitational waves, that underpins LIGO. And LIGO is opening up the first of the gravitational wave windows. And there will be a sequence of gravitational wave windows like the optical, the radio wave, the X-ray. And so this is the beginning of a whole new way of studying the universe, the beginning of a whole new set of spectral bands with a whole new kind of radiation. So this is going to teach us things about the universe that we had never imagined. I'm quite confident of that. What I saw is is called a time frequency plot. It's just these gravity wave detectors, the mirrors, were being pushed back and forth in a oscillatory way at a certain frequency that was going to higher and higher frequency, so moving slowly at first, then faster and faster and faster and faster, and then dying out at sort of a fixed frequency. And so it was plotted as a function of time, the frequency of oscillations, and it was what we call a chirp. And it was strong. It was unbelievably stronger than anything I expected to be a first detection. It was so strong you could see it by eye, just sticking up in such a convincing way. And here was the chirp at Hanford, Washington, and there was the chirp at Livingston, Louisiana, the same chirp at both locations at the same time, within the delay time for the propagation of the gravitational waves from one site to the other. And I looked at it and I thought, my God, this looks like it's it. But the interesting thing is you would have thought that I would have some sense of euphoria and excitement, but my feeling was just a sense of deep satisfaction. So a gravitational wave is a ripple in the fabric of space and time, the same way as a ripple on a pond is a ripple in the shape of the surface of the water. But the nature of the ripple is a little different. For the water ripple, the water goes up and down. Whereas for a gravitational wave propagating that direction, what it does is it stretches and squeezes things perpendicular to the propagation direction. And so instead of making things go up and down, it's stretching and squeezing, which is the key thing that the interferometer works on, that enables the interferometer to detect the waves.